computers don't listen to sound at concerts. So listening with ears was one thing that we really spent a lot of time doing. Regardless of how much measurement data we have, if it doesn't sound good, it doesn't make sense.
So one thing about the CP118 was that the cabinet actually was too small to get good efficient output for any transducer. Transducers have properties we call teal small parameters. There's a natural resonance that they want to oscillate at in the subwoofer range. They're tuned for that if their application is for subwoofers. And then there's natural volume, interior volume of the cabinet that wants to work with that natural resonance of the cone. Generally, you have to size the loudspeaker, the size of the box, to the frequencies that you're trying to reproduce.
So one of the things we had tried to do with the CP118 is make the sub as small as we could make it. So we said, what do we not like about stage subs now? Some of them were very bulky. And when you're trying to build those into a set or a concert stage, as a drum monitor or a bass guitar monitor, side fills, size was an issue sometimes. So we took the cabinet and made it as small as we could make it to fit an 18-inch speaker in it. We were having success, and then we decided to change gears and go into a self-powered architecture. And then at that point, we saw a very large gain in performance that couldn't be replicated with an unpowered speaker. So we've made up for the small volume of a CP118 with pretty much sheer horsepower. And that design, we saw success with that. That design evolved into the CP218.
We had to take the next step with the CP218. The predecessor of the CP218 was the BT218, and the BT stood for bow tie, the shape of the port in the center. The BT218 was great, and it had a great foundation. Physical size was correct. The location of the ports, locations of the transducers were all correct. And the industry needed something that was a little bit louder, but not bigger. And so with the CP218, the only way we were going to be able to improve and greatly increase its output was to change the fundamental technology of the drivers. And to do that, we took technology from two companies that partnered together, one a transducer manufacturer and one an amplifier manufacturer, to make something that didn't exist before, that could work together to create more excursion on the transducer while remaining linear.
During the design process, we would test the drivers pretty much until failure. We would test them not only with pink noise or other test signals, but we would run kick drum, acoustic instruments, electronic music. We would run every signal that we thought could get run through it, and we would run it as loud as it would go. We would test everything to its limit, and we continually did this until we got it to a point where it was essentially not failing, and that's the transducer that is in the CP218. So the CP218 is self-powered because we were simply unable to achieve the performance with a conventionally powered system. During its development, we had explored multiple different architectures. We had started out with a conventionally powered system, and once we started exploring the self-powered architecture with the low impedance transducers and the pressure sensor DSP, we discovered quite quickly that performance wasn't able to be achieved in a conventional sense. The cabinet has a pressure sensor that measures the pressure inside and outside of the cabinet, and that's fed directly into the DSP. And in real time, speaker nonlinearities are corrected. Rather than having to guess essentially what the transducer is doing, maybe at the end of a several 100-foot long speaker cable, the DSP can realize through the pressure sensor what the transducer is doing, correct that, maximize the excursion before damage, and really offer a lot of control in addition to the high power.
Actually, the output capability is so great that it allows us in many applications to use fewer of them. So not only is it in and of itself relatively small, given its tremendous capability, but you can also use fewer of them to achieve the same results for large venues and large shows. So we get kind of a compounded benefit.
And with the CP218 really allowed us to maximize performance in some modern touring type of designs in which the subs are located all around a venue, flown, stacked everywhere. We can now run AC cable and eliminate which is a much less lossy cabling system than speaker cable, and really maintain an exclusive level of performance that you cannot get with a conventionally powered system. We have a lot of experience with different configurations, and our application engineering department does have the ability to use it as essentially a universal low-frequency building block to integrate well with any of our sound systems. At Cohesion, we can draw on decades or more of touring experience. These events get set up quickly. It's a very fast-moving environment, and the attention to detail in the design really offers up a really great improved user experience for the people that are doing this every day. By covering the details in the design, that sort of means that they don't have to on the road. They can know that everything is designed to work well together as a system. It's designed to be rugged. It's designed to be high performance. You're going to get exactly what you want out of the speaker every day with maximum sort of reliability and efficiency. So by designing that from the beginning into the Cohesion products, that detail-oriented design philosophy does provide a really improved user experience for everybody on the road.
The design priorities for the CSB218 were to remain true to the output characteristics that everyone's used to with our 18 subs, as well as the look. And we were also working to make something that would offer a few user benefits for cardioid applications in installations, both functional and aesthetic. You can see that the back of a CSB218 looks like a false front, so it looks more uniform from a distance in an install. When deploying the CSB218i, we provide processing in our amplifiers for pairing with our Cohesion arrays, both in ultra low frequency format or in cardioid format, in addition to what we call standard format, which is more of a, I'm using a sub, it's pointed to the people. CSB218i has 18s that are high performance new 18-inch motor technology that surpasses prior designs for the non-powered subwoofer, and ability to deploy these as a cardioid array in particular is something we paid attention to with little design details, specifically relating to rigging accessories and the design of the cabinet itself, along with front and rear input connectors to keep the cabling clean when installed. The powered amp in a CP218 offers some unique benefits, and we wanted to try to make a sub for the situations where a CP218 wouldn't work for whatever reasons without compromising the acoustic output. The CSB218 shares common bracing, common tuning, common porting concepts acoustically. However, it's tailored specifically to non-powered drivers that allow it to be installed with a remote mounted amplifier.
Well, the CSB218i was really designed to round out the product catalog for Cohesion in an install-specific application. Now we can bring high-performance, modern, low-frequency cabinets to any fixed install. So by doing that, we really have provided a complete system solution to the client. An individual speaker does not make a sound system. It's the loudspeaker, it's the cabling, it's the amplification, it's everything working symbiotically as one.
The CSB218i is made with premium Baltic birch, built by our wood shop here in Pennsylvania.
I mean, when we come up with the design of the wood shell, you always have to take into account how our wood shop is going to build it, because we build everything in-house. We machine everything in-house on our CNC machines. So you have to think about, how is the man who's coding it, is it going to be easy for him to code this part and make this part? Is it going to be easy for the wood shop to figure out how it goes together, and then is it repeatable? You know, that's the one thing. Years ago, we started the design around what we call material tolerancing, where we get wood from the mills, but all of the different thicknesses have different tolerances on it. So because the tolerance thickness of the wood can change, we machine every single part where they mate with other parts, so that we account for the material tolerancing, and every single box comes out the same. It makes the design a little bit harder, maybe a little bit longer to do things, because you have to work through that with everything. But what it ends up doing is making tons of boxes that are identical when they come off the assembly line. And then because it's machine surfaces everywhere, the joinery is stronger, it's just more reliable, and it doesn't matter who builds it, it always goes together the exact same way every single time. If it doesn't sound good, we just start over. We've developed boxes in the past where we've made 8 prototypes, and the acoustic guys just were not happy. So it was back to the drawing board, start from scratch, just throw everything out and start over. At Cohesion, we've just gone back to the drawing board many times with stuff. And in the end, we end up making this really, really good product.